לא, חאוויה. קורה. 9-10. סוואגר? נשלח לך לינק יותר. קוראים לזה סוואגר. אז שהיה ארבע. מה הוא היה? לא, זה סתם.
כנראה. זה הרצאה שמועברת כרגע בלייב, שרציתי ללכת אליה, סתם רציתי לראות איך זה נראה כשמתחברים מזה בלייב. קוד, נו. לא, זאתי בטוח שלא. היא לא, כשהיא לא מספיק יפה.
הם הכי פחות כאילו, יראה ממש פנס.
כן, נראה לי האמצעית.
זאתי?
נראה לי. היא פשוט יחסית פשוטה, היא צריכה עם ג'ינס.
Это Хаулям. Второй. Да, у меня я поставила там поставил уже да, ну я шла по группе, да, советую. Ворами есть, да. Оушена, Мадонна, а Валентом... наш я что делал? Думал, Исаак там. Хочу поставить больше машин. Ну, больше Исаак, мат. Хочу марки, цветок, в общем. Да, коктейли будут разные. Тоже, например, сверху, что-то поставить. Я специально слушал, я делал ляуши. Не, можно по-другому, можно подальше. Внешне я мехусь. Определенно мои 192 маркет, а точка 2, это вообще не мэпы, что? Я не мэпы, ты вообще. Я только пишу, что он экспоз. Вот, 80 файл. У него получает какой-то IP, все, а на хост он мапится вообще, есть такое возможность. Как он уже мапится? Он не мапится. Тогда если пойду по локальному, который он получит, рассадывается. На 8 на 8 найдет. Это модель пока не слушать. Короче, не знаю, я думаю, как я пришел к тому, что все происходит. Одна машина, сайт, маркетинг. Покупать я на нее очень большой. Больше плачет,
Открывается смех.
טוב, ברוכים הבאים כולם. מקווה שאתם יודעים שהגעתם למיטאפ של דוקר, מי שלא יודע. אנחנו נפגשים פחות או יותר פעם בחודש, או מתי שיש אנשים שרוצים לתת הרצאות, אז כולם מוזמנים להגיש הצעות להעביר כל מיני דברים. היום יש לנו את אדם מגיגה ספייסס, שידבר על דוקר בפרודקשן, שהוא יהיה הראשון, ואחרי זה, אם הוא ישאיר מספיק זמן, יהיה 10 דקות, רבע שעה הפסקה, ואז יהיה גם הרצאה על סקיוריטי. זה מוקלט ביוטיוב, מי שצריך, והמרצים, אם תסתובב מול המצלמה, אדם, תסתובב מול המצלמה, אז גם תהיה מצלמה.
So I'm just going to wait for everybody to take their seats. Would I have to use a microphone? Can everyone hear me?
You should use mine.
I will. Hey. No. Yes. Great. So, hi everybody. I'm Adam Ravi. I'm a software developer and I work at Gigaspaces. And at Gigaspaces, I work on the Cloudify team, where we provide a solution for automating and orchestrating your applications entire life cycle through the deployment and onto autoscaling and healing. And we try to give that solution out of the box using Cloudify. You could take your mission critical applications and orchestrate them on the cloud. Now, the cool thing about Cloudify is that it basically lets you model your application so that you won't be binded onto your infrastructure. And that's kind of important for those that need to be able to port their applications from cloud to cloud. Say you're working with AWS and you want to port yourself to OpenStack. That's a very useful tool, and it allows you it prevents lock-in to cloud orchestration. To cloud, I'm sorry. Now, today's topic is going to be Docker in production, and I'm going to talk about the pains and gains, mostly in our production, in terms of porting to Docker. The topics I'm going to go over today are, okay, so I'm going to start by an introduction to our use case. I'm going to introduce basically I'm going to talk a bit about the reasons why we chose to use Docker on production. Then we're going to kind of take a deep dive into the process of porting our application to Docker. We have an existing application, and we really wanted to be able to take our application and port it to Docker as easily as possible, and that process presented a lot of advantages. Doing that process presented a lot of advantages, but it also has its disadvantages. I'm sorry, guys, why didn't you tell me that I wasn't showing my Jesus? Jesus. Excellent. So, moving right on, we'll discuss. No, I won't repeat. Okay, so this is kind of the beginning of the talk. So, after I'll talk about what it meant for us to port to Docker, I'm gonna point out 3 major pains and gains of having porting to Docker. There are probably a lot more, but I'll be focusing on those 3 since they were our major advantages and disadvantages in our environment. Finally, and hopefully if I'll have time, I'll review some best practices in terms of how to build your Docker images and how to maintain your Docker images throughout the process of using Docker. So, okay, so let's start with the intro, okay? So basically, on Cloudify, we usually work with clients that are enterprises. And our story is that we usually get to a customer and we tell them, and we have a long list of prerequisites that we need to have in order to be able to bootstrap ourselves onto his environment. And that means that we're coming to a customer and we're telling him, okay, so we have this application and it's running and it's pretty good, but you will have to have Ubuntu inside in your infrastructure. You will also have to have a very specific version of Ubuntu, in addition to internet connection and a very specific version of Python. So usually that doesn't fly. A lot of customers have their own data centers and their own requirements and their own restrictions. And it would really be nice to be able to provide an out-of-the-box experience for our application, meaning that we could bootstrap ourselves potentially onto as many OS distributions or environments as possible. So that's the reason why we chose to look at Docker and to start testing Docker, and specifically in our environment. Even though it's a pretty new product, and it required a lot of guts and a lot of we had to go through a lot of things. So first, I would like to know who of you have ever played around with Docker? Did any of you? Yeah, good. That's great. So this next part is going to be pretty much dive into implementation details. So I'm going to try to keep the people that haven't really played around with Docker in line. So I'm going to talk a bit about some common patterns, and hopefully everyone here will understand what I'm talking about. So on to my next slide. Okay, as I mentioned, at DeepSpaces we have a multi-tier application, meaning that it's made out of a lot of services. Now, porting to Docker for us, or basically for any one of you, if you use it right, meant we had to have every service run inside its own container. And in turn, what that meant was that each container has its own file system, but each service should also be able to share files with other services. And now each container has its own network namespace and IP, but still we have to be able to, for services to be able to discover themselves. Now, having said that, we're also in the mindset of having as minimal base images as we can. That's kind of Docker's best practice, and what it means actually for us in terms of porting is that if we were used to be able to deploy ourselves onto, say, Ubuntu, then now we would want to be able to deploy ourselves onto a whole different image, and we would want to keep that image as minimal as possible. We wouldn't want any binaries that are not relevant for running our service on that container. That's for security reasons. We really wouldn't want any executable binaries on our image except for our service. And okay, so after we went through that stage of kind of separating all the services into different containers and building them and having that process kind of made up, we went on to handling our services that required persistency. Now, when I'll talk about persistency, I'll be talking about services that, when I talk about services that require persistency, I'm talking about services like databases that write their information onto the file system. And as I mentioned before on the previous slide, each container, each service has its own file system. And Docker doesn't guarantee persistency, and it actually wants you to separate your data from your service. And so I'm going to talk a bit about the data container design pattern. Has anyone heard of it? This is a bit tricky, okay? So if you haven't heard of the data containers, then you might want to pay attention on this on the specific slide, because it's a bit hard to understand. Now, since according to the Docker way, if your service fails, then you wouldn't be able to access its file system anymore. Then Docker presents a new container pattern called data containers, which means that if you start a service that requires persistency, you would have to tell it, you would have to use a data container, which acts as sort of a mountable device. So we would have to define a device that is mountable. It's actually a container that has volumes that are mountable. And you will start your service and tell it, use those mountable paths for persistency, and you'll be able to totally separate your service from your data in such a way that if the service crashes, you wouldn't really care. Now you have all your data inside volume containers. So that's kind of Docker's way of guaranteeing that your data does remain persistent. So in our case, it meant having all our services that require persistency have their own data container. And okay, so we went through that stage, and like the next thing that I'm like,
when you say it's mountable, is there a first model or
what do you mean?
So the interface between the non-persistent container and the data container.
Yeah.
What protocol is that?
I'll try to answer that in our next slide or after the presentation. Okay, because not entirely. So after doing all of this, this is our final result. Now I really don't intend on going into this slide in a lot of detail, but basically I have it here in order for you to understand. It's a big architectural change. Okay. Now we have services that require persistency, such as Elasticsearch, and Elasticsearch. That means that now Elasticsearch is made out of a service container and a data container, and we have services that are able to talk, to communicate with each other using data links, and we also have sharing of files between containers, which is something that data containers also provide. And if we look at it from a file server perspective, then it would probably look like this. Now, this is a slide that shows our file system. Okay, so this is our host file system, and Docker writes all of its data or all of its file systems onto a very specific location under var lib docker. This is kind of comfortable in terms of, you know, you're able to clean your machine. It doesn't leave any trace on your machine, and it can provide like the basic recovery ability, you know, by just having these file systems mounted onto an external volume. You could then potentially recreate your environment. That's a very, very basic recovery ability that we gain. Now, okay. So this is so we talked about our porting process, and we really didn't go into details because it has lots of bits and bytes, and I didn't really want to get into it because it's hard, and I was afraid I was going to lose some people. Next slide is kind of the interesting part, where we're going to talk about the three major benefits we got out of Docker. Okay, so I tried choosing these benefits according to what gave us the most benefit, but I kind of tried choosing these advantages in a way that, you know, you could this would be kind of generally relevant. When we're talking about you know, porting to Docker, so most of you probably heard of the advantages, having your build be built once and run anywhere is kind of a major thing. Where it's easier to ship, and build management becomes a lot more organized. So I'm going to start with the first advantage, which basically means build once, run anywhere. Now, when I say build once, run anywhere, it's not entirely true. Okay, so sometimes for instance, like Docker runs only on Linux kernels, and we all know that. And Docker also requires a very specific kernel version that doesn't support the old kernels, but it does open up a lot of opportunities. We are able to create a deployment that is portable across machines, meaning that we really don't care about the underlying hardware. That being said, it's the underlying hardware or OS distribution don't really mind us in the bootstrapping process. Our images are more time resilient in the sense that we are able to be time resilient and be able to run our application 10 years later if we want it. The other reason why build once, run anywhere is very good to have for us is the fact that it's very open source friendly. Now, the Cloudify product is an open source product, and we would really like users to be able to pull the code, make code changes, build their own builds, and share images. That's a great ability, and it's very straightforward when you use Docker. The next benefit that I'm going to talk about is shipping, and that was a very big pain point in our product. As I said, we would like to make our deployment process as seamless as possible and as easy as possible, so to provide a first experience that is very easy. But other than that, we also require offline installations, because a lot of times we get to a company and we do need internet access, but they're running on a private cloud and they don't have internet access. It's kind of a common scenario. So offline deployment is a very big advantage in that term, and also in terms of having a single build path, meaning that we don't care about the system level dependencies that are on my host machine that I'm bootstrapping onto. Specifically for us, we are using Python 2.7, and it's kind of a very big mess to get to an environment that's running Python 3 per se. And trying to downgrade that Python version, especially if you're using CentOS, it kind of screws up your YUM install. There are a lot of problems with that. Now the last benefit that I'll be talking about is the build management. We were able to versionize our builds in a way that we always used to use versions, and we're working in an agile environment, and it's very beneficial for us to have the build itself versioned with all the system level packages, so that we could, for example, take those builds and recreate environments. We could use it for support purposes, and I will talk about CI dev a bit in like a very small comment, because it's still work in progress. But Docker does offer a great framework for building your images, and like for us, the dream is to be able to, once the code change happens, to be able to have our build time be determined by the time it would take us to compile our code. And it's work in progress, okay, but definitely seems to be able to go there, and we're going there. This is like the last benefit that the last major benefit that we got out of Docker. But if you're okay, you have your mindset on, okay, I'm going to use Docker and everything is good and everything is perfect, then you might want to stick around for the next part of this presentation, because that's where I'm going to kind of talk about the pains of using Docker. Docker is great. The first experience of using Docker is awesome. For those of you who played around with Docker, it's pretty easy to use. It's very intuitive. But when you start handling the real when you start really getting deep down into the Docker implementation details, then some things become a little harder than you expected. So again, I chose to focus on the 3 major Docker pains in our environment, and I also think that these pains are very relevant to a lot of people that are working on putting themselves to Docker. Having to put our code or application to Docker meant that we had to make code changes. That basically means that if we found a bug in our implementation or a bug in Docker or something that's holding us back, it kind of makes it a lot harder to be able to roll back our changes. Things like having Docker not fully matured are kind of still a problem for us. We've been starting to work with Docker since the 1.0 version. And for example, Docker exec, the command that enables you to go into a container and be able to SSH to it, kind of wasn't introduced until Docker 1.3, and it still has a lot of kind of missing features, I would say, and the hype around it is great and all, and it does serve our purpose when we come to customers. We don't have to explain to them, listen, this is Docker. They already heard of Docker and everything is cool, but the hype is also kind of a bad thing, and I'm going to address that as well. So starting with code adjustments. When you're building your deployment process, as well as when you're kind of porting your application onto Docker, it means that you would eventually have to make code changes. So it's up to you whether or not you decide to implement another path that's only relevant for Docker, or having a single path for Docker. But it's something that you would have to take in mind. You would be Docker locked. Okay. The second thing is secrets and runtime assets, things that would require you to change your attitude in ways you think of how you handle your assets. You will have to start thinking about how you're going to hold your secrets. Monitoring will most surely change since now every service is running inside a container and it's not running on my VM. So that's totally something that you will have to consider being able to do, especially if you're working with, say, I've heard a lot of people that are having problems with monitoring their Java application, since they're using JMX, and JMX use RMI to open a random port, and random ports is not something that Docker really likes. So, but other than that, if you would want to have, to gain information about your containers, you would probably need to have access to the host machine. You would need to use Docker or cgroups to get matrices about your memory and CPU usage. It's a whole process. Next pain I'm going to talk about, and that's a very painful pain point for us. Okay, multi-tier application, a lot of services. That meant that we had to ramp up our entire R&D team. Now, it's more than just a ramp up, because now developers are going to have to start thinking in container-oriented solution mindset. It's kind of similar to the way they used to think up until now, but it's also kind of different. And in the cases where developers that are working in development environments would want to be able to debug their code, and it's kind of a mess to be able to debug your code. And Docker is trying to give a lot of solutions for that. There are a lot of container patterns, and I felt it was necessary to mention those patterns, but I won't go into those patterns. And these patterns offer a lot of solutions for developers. Because as you remember that we talked about minimal images, we really wanted to have as less binaries in our image as possible. That means that now if a developer is going into a container and first say he wants to edit configuration files or stuff like that, then he won't have a VI instance. He would probably not be able to download stuff from the internet since it doesn't have wget or curl installed. And in general, the additional abstraction layer that Docker adds to our architecture is kind of complex. You have to know that architecture in order for you to, say, be able to copy a file onto a container and things that were kind of trivial to do before. Okay, so I think this is kind of the last pane that I'm going to be talking about. So monitoring is something that Docker is working on. But the main issue with Docker for us, and probably for any of you who are considering putting their application to Docker, is the fact that Docker is not widely used in production. And it's hard. I mean, okay, when VMs first came out, you know, there were these skeptic people that said VMs can't share memory. They can't. For sure, I'd be able to be on my VM and access the memory on my bare metal instance, and there is no way we could consolidate all of these things. Now, we're totally sure that everything that will rise, I mean, any problem that would be found would be fixed kind of fast. Whether the problem would be in the kernel or in the Docker implementation, we are kind of sure that Docker will handle these issues pretty fast and pretty efficiently. But still, porting to Docker or using Docker in production, still a lot of hype around it. I won't go into security since Dima is here and he's going up after me, and you know. But still, we don't really know about. We do know that there are security limitations, and security is kind of a big deal when we're talking about enterprise customers, and it's very important to have. So, having said that, and I hope I didn't miss anything, these were kind of the pains and gains for us for using containers, and I really hope that you're able to get something out of this conversation and like out of this these pain points and advantages, and think about them when you start implementing Docker in your environment, or when you start porting your application in your environment, because these are really things that should be taken in mind when you're using Docker solution. Now, okay. So we're making good time. So this is the final part of our presentation before questions and answers, where I'm going to talk about building Docker images and having best practices for building Docker images. Okay, so the first thing I would like to talk about are base images. Now, base images work really good for us in the way that we have the same base image basically for every service. Every service that we are running as part of our application uses the same base image. And since Docker is optimized to be able to share underlying file system layers, it means that if I start, say, 10 services and they're all running on the same base image, it means that Docker will know how to reuse those underlying file systems and not create a very big, and not take a lot of space out of your VM, and that's kind of great. Which leads me to the next tip about building your Docker images is we found that it's very convenient for us to be able to reuse our service our service container both as a data container and as the container that's running the service. And I'm gonna explain why. Basically, we would like to have say we're running Elasticsearch and we would like to initialize some indexes. We would like to create some tables, and we would also really like it if we could start the image and have all that data inside that image. Now, if you're using the same image for service and data for the service and data container, what it actually means is that you could use that you could have your data already located in the destination that you would want. And since we talked about how Docker knows how to share underlying file system layers, it's kind of efficient. It's actually the Docker best practice. So if it works for you, I mean, if you do want your data to exist, I mean, your pre-made data to exist inside your image, then I do recommend having using this approach. And next, I'm going to talk about volumes, and specifically, I'm going to talk about volumes inside your Docker file. Now, Dockers, last time I checked, have to be set at runtime anyway. Even if you do define a volume in your Docker file, if you want Docker to look at your container as a mountable as a mount point, you would have to explicitly mention the volume at runtime. So why would it be good to have the reason why it would be good to have it in the Docker file as well is the fact that when you that it's very user friendly, meaning that anyone who's using your image will be able to take your image, run a Docker inspect on that image, and he would be able to see which volumes should be persistent, and thereby using your service the correct way and starting a data container and knowing exactly which mount point you should use, and also which port your service exposes and which ports he might be needing to forward onto the host, so to the host network. So state volumes, state, all of these things. Your image metadata is very important. It gives you a lot of information about your image. Now the last advantage, and this is kind of long, and I'm going to need you to stay with me on this one. This is our use case for using a Docker file for Elasticsearch. And I'm going to go over it from start to bottom. We're using a Java-based image that is shared among all our Java processes, all our Java services. And underneath that Cloudify Java-based image, we are running Baby and Jessie, which is a very minimalistic image. It is really nice to be able to configure. It's really readable and really nice to maintain. Having versions in environment variables rather than inside your bash commands, and this part is like the part that I would want to hold on a bit about. Okay, so some of you know and some of you may not know that whenever you run a run command, it creates a new file system layer, and it has the files, it puts the files inside that specific file, that specific layer, and that means that if you use run to update and install curl, and then use another run to remove curl, it means that curl is still inside your images. It's just located in a different layer, but it doesn't mean that the binaries were actually removed. That requires us to bulk all of our operations at once. And here we could see, okay, we're running apt-get update, and we're installing curl. Then we're installing our installation files, and we are starting Elasticsearch in order to initialize indexes. So that's pretty cool. I talked about how we are reusing images both for service containers and data containers. The next thing we do is we remove all of the stuff that we just downloaded. We remove curl, and we use auto remove for apt-get. This allows us to have a very, very minimal image, and with as much layers as possible. Now that being said, you could take your image and then compress it and have it have all the files under the same layer, but we prefer to use this approach. Volume is stated. You could also play around with having setting your path, your actual container path. You could add Elasticsearch to your path. We didn't do it here, but you could access your path and change it, and it's kind of awesome. And that is all, I think. Okay, so this was my talk on our process importing the containers. I would be happy to answer questions. Yeah.
You mentioned it's necessary to change the code and Docker lock.
Yeah.
Can you give an example of how you change it?
I'll give an example. Now, as I said, we're running a multi-tier application. We need services to be able to discover each other, and a lot of times it means going into the code. Since now you're not running on local host on the same machine, you would have to have the services know where they're sending their requests to.
So you're talking about service discovery and configuration and stuff like that. It only refers to the URL.
Yeah, and there are that changes. You would have to make monitoring. You would have to add monitoring. Your monitoring would probably stop working. You would have to. You would have to make. You would have to make changes in the way you are handling your logs. Probably you would have to do all this stuff that would allow you to run kind of the most recommended way that Docker recommends.
What about performance on the AWS, for instance?
So performance is I don't want to advocate for Docker, okay, but performance-wise, CPU is kind of almost is native, and memory usage is almost native, and you could play around with it and have memory performance that are native but you would have to play around with it. Regarding network and regarding really a problem for us.
Assuming that you're running everything on one host is okay, because all Docker has a random IP bounded to the same host. But assume that you're going like cluster, and you have 3 or 4 nodes. One of the nodes, let's say, fell down, broke, whatever.
Are you talking about high availability?
Yeah. How did you manage knowing where the services are running? Because running fleet doesn't allow you to know exactly where the service is running.
So that's kind of a problem, but we haven't yet got to. I mean, we're working now on a highly available solution. So I wouldn't be able to give you the best advice on how to overcome that problem.
Only Sky DNS allow only knowing on the same host where the container is running.
Maybe you could consider having a container running at DNS. Sorry?
Currently, I played with Sky DNS.
Yeah.
That allow you to know where the containers are running. You have a DNS that is running, and you have a name to the same container.
Right.
When you putting one down, then you bring one up, it's the same name, so it goes to the same IP.
Right.
But when you're going from host to host, you have a problem.
Right.
Probably I didn't find a solution, so I thought maybe you already walked the same path.
I'm sorry, but I would be happy to sit down with you, help you try to work out with it. I can't think of anything out of my head right now.
EC2 Container Service gives you ELB component. I mean, it just manages ELBs for you. So that could help if you're running many.
There are several current solutions that are being worked on, starting from etcd by CoreOS and SkyDNS that was mentioned, Kubernetes. There are all kinds of current solutions you can look into. None of them are currently considered best practice or fully matured, but you can play with stuff, and some things do get.
I know there is a swarm, but now it's
Yes, there's also that. CoreOS would like to tell you that their solution is mature and production ready and excellent. So that's one way to look at it.
Do you have some Docker orchestration tool? Orchestration, or is it manually deployed?
Currently, we use Cloudify to deploy our application. Cloudify it does help and orchestrate applications on the cloud, and it doesn't really matter if they're Docker based or not Docker based. But we have our own implementation of deploying our code onto the server.
Again, for people that want to do that, to do orchestrate multiple containers on the same host,
Yes.
there is Docker Compose from the Docker guys.
Right. We've actually worked with Docker Compose, and we found it is a great tool in order to be able to build and automate your builds and stuff. But it did present us with some problems in some cases where we had to use Docker in a non-trivial way. So we kind of gave up on using Docker Compose for now, but it is a great tool. We were using Docker Compose for Fig, and I mean, back when it was called Fig, and back then it didn't really have linking support. And you know, it's a nice idea to be able to have all your containers deployed by Fig, but you know, there's usually stuff that you have to take in mind, like you'd have to treat your runtime assets in some way. Maybe you'd want to copy files at runtime, at deployment time, and these are kinds of things that we kind of had to go really not in the direct way in order to achieve them if we would have used Compose. Yeah.
You talked about how you remove binaries that you don't want from the image while you're building it. I've seen a trick that some people talk about on the internet where you have a builder Docker image that you're building it with everything, and then you export through tar to another build process, which takes only the thing that you need from the image. That way you can get rid of dependencies pretty quickly. Have you looked into that?
I haven't actually. I haven't heard of this kind of solution, but if you're interested in these kinds of patterns, I don't know. I mean, I wouldn't be able to help you. I'm kind of referencing some of these container patterns in my documentation, but I have never really played around with these kinds of solutions. So yeah.
Are you adding all your configuration for the services at the build time, or some of them are you just mounting when you just running?
Yeah, so that's the point. It depends, because some configurations we would have no problem building into the image, and some configurations would have to be set at runtime.
How you divide it? Which examples?
So it's kind of application specific. It's kind of it has a lot to do with what you want to be able to achieve. But yeah, basically it does mean that you will have to give a solution in the form of mounting volume onto the external file system and copy, and then having some command copy that file. And if you want that configuration file to remain persistent, then you would also want it to be in a persistent path inside the data container. And that's kind of also something you should consider. So that's why I said that it's kind of, it depends on your implementation.
Can you try to generalize which kind of configuration, in which cases you would put in real time, which kind you would put in the...
You could try that, but there are always the exceptions, and each use case has its own. We usually use a single Nginx configuration, and our Elasticsearch configuration rarely changes. So it really depends on your use case.
So you adding Nginx configuration in runtime?
Yeah.
Okay, and what you add? Sorry, in build time.
Let me interrupt. Sorry. So I want to have a 15-minute break. You can ask Adam questions during the break, of course, and I guess he'll remain after the meetup as well. And we'll have Dima from Twistlock in 15 minutes talking about Docker security. Another announcement next week, for those of you who are interested in Docker and managing multiple containers, there's a meetup on the Israel AWS group about ECS. So if anybody is interested in that. And I see you in 15 minutes.
Just a second, a quick thing before you go. Okay, thank you.
One more question. Can you post this page somewhere we can all see it?
Yeah, and I'll consult Evgeny on how to do that so that everyone here will have access to it.
לא שזה כזה